Today, I'm going to be talking about photoreceptors. First, I will give you a quick summary about them. Photoreceptors are nerves in your eyes, and there are two different types of them. There are rods, and there are cones. Rods help us see in the dark, and cones help us see all different types of color. Rods and cones are called after what they look like. The outer segment of a rod looks like a typical rod, and the outer segment of a cone looks like a typical cone. The bottom segment, commonly referred to as the inner segment, looks the same in both rods and cones. They both involve a nucleus, and they both involve mitochondria. The nucleus is found here, and the mitochondria is found here. In each structure, there are optic discs. Optic discs are large membranes found in both rods and cones, and there are thousands of them. Rods have many more optic discs than cones do. The more optic discs there are, the more sensitive the photoreceptor is. Since rods have more photoreceptors, they are about 1,000 times more sensitive to light than a cone is. For this reason, rods are really good at detecting light, and rods are responsible for telling us if light is present or not. On rods and cones, there is a bright red photosensitive protein on them, and they are found on both rods and cones. On rods, that protein is called rhodopsin, and on cones, the protein is called photopsin. These proteins play a vital role in humans being able to see in the dark and being able to see color. When the light enters the rod and hits rhodopsin, it sends a nerve impulse to the brain, and the brain will form an image. It is the same for cones. When light hits photopsin, it will also send a nerve impulse to the brain so the brain can form an image. Other than the shape, those were the similarities. Now I'm going to be talking about the differences in cones and rods. In the retina, there's about 120 million rods, but there are only about 6 to 7 million cones. Now I'm going to be showing you where rods and cones are located. In blue, I am going to be drawing the retina. In black, I'm going to be drawing what belongs in the periphery of the eyeball. The thing that belongs here are rods. There is a part in the retina that caves in just like this. This part is called the fovea. The fovea is where most of the cones are concentrated. When light comes towards the eye, it refracts off the cornea towards the lens, refracts again off the lens, and directed towards the fovea where most of the cones are concentrated. There are 3 types of cones. There's the red cone, which takes up 60% of all cones. There's the green cone, which takes up 30% of all cones. And there's the blue cone, which only takes up 10% of all cones. Rods have a very slow recovery time, which means that they adapt to light very slowly. For example, if you're outside in the sun for a while, then you go into a dark room, you will not be able to see until your eyes adapt to the dark. This could take 30 to 45 minutes. On the other hand, cones can rapidly adapt to the change of illumination because they have a very fast recovery time. An example of this is if you come out of a dark room into the light, you will be able to see normally after a few seconds.